Yesterday in class, you did this compound ratio assignment on the online curriculum, and a few people struggled with it. So I'm just going to go through our workbook, and if you turn to page 22, I'd like you to fill in the tables on your workbook while I do it too. That way we can go back over it next week and just make sure that everybody has everything correct. Problem number 1 says, determine the smallest ratio of elements in each compound. Next, using colors or shapes, illustrate a model of the compound. Remember to include a key. Compound A is 67% oxygen and 33% carbon. If we write that ratio, we have 67 to 33, but we can reduce that because 33 goes into 67 2 times. If I reduce this to the smallest ratio, I would have 2 oxygen to 1 carbon. To make my compound model, the directions tell me to use colors or shapes, and I have to remember to include a key. I'm going to use a colored in circle for oxygen and an open circle for carbon. If my ratio is 2 to 1, that would mean I have 2 colored in circles to represent the 2 oxygen and 1 open circle to represent the carbon. Some people also chose to write the ratio instead of drawing it, which is fine. You would have 2 oxygen to 1 carbon. Now for compound B, the beginning ratio was 80% to 20%. So it was 80% hydrogen and 20% carbon, but we can reduce that ratio by dividing both sides by 20. If I divide 80 by 20, I get 4. And if I divide 20 by 20, I get 1. So this is telling me that for every 4 hydrogen I have in this compound, I have 1 carbon. And I'm going to use the colored in circle to represent hydrogen and the open circle to represent carbon. When I go to make my model, I would have to draw 4 colored in circles and 1 open circle. Or I could write this as 4 hydrogen to 1 carbon. Compound C is 50% magnesium and 50% oxygen. Since both numbers are the same on either side of the ratio colon, I can reduce this to 1 to 1. I'm going to use the same symbols. The colored in circle represents magnesium and the open circle represents oxygen. When I do my model, I would have 1 colored in circle and 1 open circle. Or if I'm writing this, I have 1 magnesium to 1 oxygen. Now the last compound has 3 different pieces to it. We have 40% hydrogen, 40% oxygen, and 20% magnesium. I can divide all of those numbers by 20. So to make my smallest ratio, I would divide 40 by 20, that gives me 2. It's the same number for oxygen, and then for magnesium it would just be 1. Now I have 3 different compounds, so I need to come up with a third symbol. For this one, I'm going to use a colored in triangle. So hydrogen is the colored in circle. I have 2 of those. I have 2 oxygen, which is the open circle, and I have 1 magnesium, which is the triangle. And if I write that out, I have 2 hydrogen to 2 oxygen to 1 magnesium. Okay, so make sure you have all of that in your table, and then we'll turn to page 23. On page 23, this says a scientist identified the element percentage of atoms in 3 compounds. Compound X is 67% nitrogen and 33% oxygen. Compound Y is 60% nitrogen and 40% oxygen. And compound Z is 33% nitrogen and 67% oxygen. Part A says determine the element ratio for each of the compounds, X, Y, and Z. That means I need to come up with 3 different ratios, 1 ratio for each compound. Compound X, we're told, is 67% nitrogen to 33% oxygen. Compound Y is 60% nitrogen to 40% oxygen. And compound Z is 33% nitrogen to 67% oxygen. So these all are correct ratios, but I need to reduce them so that they're the smallest possible ratio. From the table on page 22, we already have done 67 to 33, and we had a 2 to 1 ratio. For compound Y, I can divide both sides of this ratio by 20. 60 divided by 20 is 3, and 40 divided by 20 is 2. And then finally, compound Z is just like compound X, the numbers are just reversed. So this would be a 1 to 2 ratio. Part B says to draw a model of each of the compounds for X, Y, and Z. I'm going to split this box into 3 different boxes. So I have one for X, one for Y, and one for Z. All of these compounds have the same elements. They're all made of just nitrogen and oxygen. So I will use the colored in circle to represent nitrogen and the open circle to represent oxygen. For compound X, I have 2 nitrogen and 1 oxygen. For compound Y, I have 3 nitrogen and 2 oxygen. And finally, for compound Z, I have 1 nitrogen and 1 oxygen. Part C says, are compounds X, Y, and Z the same compound or different compounds? Support your claim with evidence and reasoning. From our notes last week, in this same elements, different ratios section of the text, we saw that nitrogen and oxygen can combine in 6 different ways. In this picture on page 23, we see that nitrous oxide is 2 nitrogen to 1 oxygen, and it's showing a picture of someone at a dentist's office. Nitrous oxide is an anesthetic used in dentist offices. Next to that is dinitrogen trioxide, which is 2 nitrogen and 3 oxygen. The picture is showing a blue liquid. So even though both of these are made of completely the same elements, the elements are in different ratios. So that should help us answer part C. The question again is, are compounds X, Y, and Z the same compound or different compounds? Even though they're all made of nitrogen and oxygen, they all have different ratios, so they are different compounds. My answer for this will be, they are different compounds because they have different ratios of nitrogen and oxygen. Okay, so make sure you have all of that information down too, and then we'll go over this next time I see you in person.